recording. Great. All right, so two talks on the agenda for today. We're hearing from Dan and Hector from VMware in the Cartographer project about securing their supply chain in Cartographer itself. And then after that, we'll hear from Chris Phillips here at Anchore about some SBOM GitHub Actions stuff. So I'll go ahead and hand off to Dan and Hector to lead us through their overview of supply chain with Cartographer. Looking forward to it. Take it away, guys.
Thank you. Yeah, thank you for having us here. We're super pumped to show you what we've been working on over at VMware. Let me just share my screen, and yeah, I should be able to start presenting as well. All right, awesome. So yeah, we're going to be talking you through Cartographer and then also ScanLink. I only have a couple of minutes here, so going to go super quick through this. But basically, on Cartographer, what we found when using Kubernetes was you essentially it comes as a bag of parts, right? And you have to figure out some way to kind of stitch together all of these pieces yourself. So the typical people that we talk to have really large teams. They'll have several development teams. They'll have kind of DevOps teams that are responsible for ensuring that those workloads are reaching a certain environment or even reaching production. And then we have other interests like the security scanning folks the security folks and the platform teams themselves. So across all of these different different people and personas, they're all responsible to a certain extent for ensuring that a workload is going to reach production. And what we found is that it really is a lot of times it's up to the developer to stitch these pieces together. And so what we've been focused on is creating a tool that allows the team, the platform and DevOps teams to create these repeatable paths to production. So these repeatable out-of-the-box supply chains is what we're calling them, that essentially stitch together all of the things that you need to ensure that when your workload reaches production, it has all of the things that it needs to be secure and compliant for your organization. And the way we've done that is by creating something called a supply chain that typically the SecOps, DevOps, the people responsible for ensuring that workload is compliant and secure, right? If you have certain kind of security requirements, they are responsible for defining that kind of supply chain. The developers themselves really focus on a very small piece of the kind of the workload definition. They're really going to identify kind of where their source code lives. And essentially what they get out of it is the kind of what we believe to be the right level of abstraction for workloads running on Kubernetes. So the developers create their workloads, the stakeholders, the DevOps, the SecOps define and kind of identify all of the things that need to go into a supply chain. And what you get out of that are running Kubernetes applications. Deploying on Kubernetes today looks something like this, right? So if you're a developer, you have to do things like create a Docker file, create an image to push, et cetera, create your deployment configuration. And essentially the way we've been thinking about this is simplifying it into a supply chain. So in your supply chain, you would define all of the kind of steps that you need to ensure, like I said, that your workload was secure and compliant. And essentially what that gives you is that repeatability. So you're able to reuse this across all of your development teams again and again and again and again. And so you always have the peace of mind that the thing coming out of your supply chain meets your requirements. The other benefit of using a Cartographer is that we've actually used a kind of a choreography model as opposed to a typical type of orchestration model. So the blocks are entirely swappable between them, and the tool itself kind of sits above all of these other Kubernetes resources. So what you'll notice here, for example, is that we're using Tecton inside of a supply chain. One of the frequent questions we get is, why not just use Tecton for everything? And the reason is that we can actually swap any of these components in or out, depending on what it is you're trying to do or the kind of the environment that you're trying to reach. So this is a very basic supply chain, right? Includes things like testing code, scanning, building an image using something like, in our case, K8s, which we use quite a bit, and then deploying to a cluster. Where the kind of security capabilities come in is, again, with the flexibility of the supply chain. And this is actually what we're going to be demoing for you today to a certain extent. So I'm going to actually hand it over to Hector, who is going to walk you through kind of at a more granular level what we've built and also demoing.
Hello, everyone. What in addition to what Daniel was mentioning, we are adding the scanning to the supply chain in a way to enforce the security and to reduce the attack surface of potential vulnerabilities. Our intention, as you can identify in the figure, is to scan the produced artifacts in the different steps. One's against the source code, and then at the end, after we build an image, it has been signed, and we scan it again. All this valuable information we have identified will be stored on what we will call metadata store, to be then used for auditing and compliance purposes. Next slide. In the following, I'm going to focus on ScanLink, which is the part of the component that we use for scanning within all this supply chain. And the first motivations, as I mentioned, are focusing on reducing these vector attacks that has companies today, adding scan toolings in multiple steps during the whole supply chain's definition, as I mentioned, source and image scanning, and then reduce with that the cost of identifying and fixing all these vulnerabilities. As we also identified, the majority of companies might use multiple scanners during the release process. Some companies might have different type of scanners for code analysis, other for vulnerabilities, or even multiple type of scanners for vulnerabilities. We have seen this use case. Next slide. As goals of a ScanLink, the idea is to support the model of bring your own scanner, right? To help customers with, especially have multiple and different type of scanners, right? We build a pluggable architecture that allows us to plug all these different type of scanners and kind of identify on the source code on our build image potential vulnerabilities. The other goals are the intention to help developers and operators to stay up to date with whatever findings has been detected during those scanning operations. And with that, we kind of include some alerting and visibility features. As well, we want to enable users to leverage all these scan results that we have produced during all these scanning jobs to prevent the promotion of any third-party vulnerabilities or third-party dependencies that we are using. In that way, we also expose a feature that we also call policy enforcement, where you can identify which parts of the steps in the supply chain you want to show a red flag because of there are several critical or high vulnerabilities, or even because we are finding a certain dependency that shouldn't be used on all this process. As well, we have we really want to keep or store all this information, which is critical for companies that we extract from our scan reports in order to be able to have some auditing and provenance verification over all these dependencies and vulnerability information that we have collected during the different steps of the supply chain. Next slide. With that, we have in ScanLink, we have considered all the features of Grype and Syft, and we have defined the usage of Grype as our default scanner, right? With that, we can also highlight other features that we have really value from Anchore, and in this case from Syft, which give us the possibility to generate the small files on demand and expose those as an independent feature when you are creating defining supply chains. In addition, we all have chosen Grype because it gives us the flexibility to generate different output formats, and one that we found really valuable was CycloneDX, which combines all these vulnerability generation and all this data about dependencies. So we can store all this information that we have been generating on the different steps and use it for adding querying capabilities to detect when a vulnerability happen, and also to kind of see which dependencies are used and shouldn't be used anymore, things like that. As our future path comes together, we would like to see support for CycloneDX and other formats as input to Grype. That would be awesome. Support of stacks of multiple small files into a single file, especially when those that have different or they use different OS distributions, and also the inclusion of attestation for the scan reports. Next slide. So the next slide highlight a bit what we have conceived as an architecture of our ScanLink component. And for us, Grype is our default scanner. And as you can see, there are different type of scanners that we can plug in, plug out. And as well, we also conceive certain plugins in a way to store all this information, to store all these scan reports that today are often either stored as S3 or attached to images. In our case, we are focusing on using them on storing a metadata store, so we can enforce after certain query capabilities. As well, in this figure, we can identify another piece that is in contact with the ScanLink that help us to provide this policy enforcement that I mentioned before, to against all these scan jobs and against all this information that we have generated during the supply chain. Next slide. All right, so then I'm gonna start sharing my screen. Please let me know if so let me know if the font is okay. Oh, that's it. Can you make it bigger? So I'm gonna show here. Well, this is a simple kind cluster where I have deployed Cartographer and I have deployed other components, but mainly I will focus on Cartographer over here. Then there is a share manager, ScanLink. We have also Tecton deployed here, K8s. So the idea is to solve two use cases. One use case is how this can be used on a supply chain. And for that, I will show the execution tree. It's not yet finished. I have triggered since we started, and it seems it haven't complete yet. But so the idea is to show you a second how this can be used on a supply chain definition. And over here, what basically we have created is a specific Kubernetes resource where you can define the different steps on a supply chain, right? So you have testing, source scanning, image builder, image scanning, and a configuration that we have on top of that. So these are the different steps. And because I didn't finish yet, what I'm gonna do is, in the meantime, so another execution where with the following file or following type of resource, I want to show the other use case, right? This use case, we are creating an image scan on demand. So basically this resource is able to define which kind of image we want to scan, which policies we want to enforce. I will show in the next minute what is the content of this policy and what we can do. And a scanning template, which is additional properties that we want when running the scan job. So I'm going to create this image scan. This can be used on any kind of cluster independently of running a supply chain. You could have your own cluster for scanning and create this kind of request. We also have source scanning kind of objects I can show, where we can see that one has been completed and is the one that is so involved in our supply chain, right? So this this kind of tree, so the different steps of the supply chain, which are being completed, which are still pending to be completed. That's why we have an unknown ready state. And what I can show is how it looked, all these scanning requests. Second. The phase is completed, which means that the scanning has finished. We can see on one of the conditions, but we can also identify that no CVs have been found, and therefore the policy enforcement has succeeded, right? So we can continue. So that's what I meant with the solving a red flag on a supply chain. Whenever we find certain CVs, we can kind of block this kind of execution or pipeline. As well, I want to show the state policy. So when I mentioned that we have a policy enforcement, we allow customers to create their own policies, right? It's a common use case to define certain policies to allow only medium and low vulnerabilities, and then raise a flag when certain additional higher severity vulnerabilities appear. So we also allow dynamically the customers to define their own policies and link to these jobs. And to finalize, so let's scan which failed, that was expected. So I will show a bit more about it. In the latest version, we have added additional information to be human readable, all this information when we kind of use the CLI in a better way, but I'm trying just to focus on the conditions to enforce it. So we identify high and medium and low, and also for potentially some unknown vulnerabilities, and we enforce a policy to raise these, and as I mentioned, we kind of fail the whole process, right? So this piece on the supply chains will be showstopper, and we cannot continue with this kind of validation of supply chains. And that was it, because I believe this hasn't fixed. Okay. Any questions?
Great. Thanks. Any questions for that? Your audio cut out just for a second there, Hector. So I wanted to make sure. It sounded like you were saying you were done and you were asking for questions, but if you're
Sorry.
Okay, just making sure I didn't want to jump in there if there was just a blip in the audio. Great, cool stuff. Interesting to see supply chain as a primitive in the system. I haven't seen that kind of called out explicitly in a lot of systems yet. So interesting to see it. Cool. Looking back. Okay, great. If there's any other questions, we can follow up in the chat as well, call out specifically. And thanks for the link, Dan. If there's anything else, otherwise we'll go ahead and
I guess
go on to
I have a question.
Sure.
I mean, maybe I'm an old fuddy-duddy still in the Jenkins world, but is using the Kubernetes Etsy server for your database that is that's tracking all your build information, and are we starting to abuse what that Etsy database should be used for, or is it now a brave new world where we're just tracking everything in the Kubernetes Etsy?
Well, I know on Cartographer, we've had a lot of discussions about that. Like etcd is size limited, I think, by default, right? So for us, we know we need like an external data store to track a lot of those kinds of things in the long term. Also, we're really focused on things like attestation across all the elements of the supply chain. So storing all of that on etcd is just not sufficient. So yeah, I believe there are other projects that use it as like an intermediary, or you have the option to select whether you want to use your data in etcd or kind of dump it out to an external data store. But so it's not a straightforward answer to your question, but we've definitely been talking a lot about where the data should go.
So do you have a Kubernetes cluster that's just dedicated to being your build, essentially, or and then are you deploying to a completely separate, like in the cloud, the actual end application? That's a separate Kubernetes cluster, I assume.
Yeah, absolutely. It's extremely flexible, so able to support any kind of your deployment topologies, your cluster topologies. So we don't have a kind of a really strong opinion about what it should be, but our kind of where we're at right now is exactly that. Like, you would have a build cluster that would be responsible for ensuring that all of your stuff was built and signed and verified, and then from there it would really be a matter of promoting that image across whatever environment or doing additional kinds of testing that you needed. So you'd move it down to a staging and cluster, or even namespace in some cases, if you have a super huge cluster. But yeah, usually promotion across environments. And the way we're thinking about that with Cartographer is all via GitOps. So having all of your configuration in an external repo, and then just handling updates to it, and then promotion across environments that way.
Yeah, so essentially there'd be a Kubernetes cluster is basically replacing what Jenkins is probably currently doing, is what and I could imagine that if I had a dedicated cluster that I could control what's going on with its etc in the database, and maybe that's the mindset I need to start thinking in, is just replacing that monolithic Jenkins server with a cluster that has all that configuration information.
Thanks. Great question. I think that's one of the
I got one little question, if you don't mind. Sure. On one of the slides, you had a picture where you had the signing of the image right before the scan. This puzzled me a little bit, because I thought maybe it's a better idea to first scan and then only sign if the scan is valid. Is there any reason why you sign first and scan afterwards?
Well, so there is no really. I mean, the choice is not really, let's say, written down, right? Like, so it depends on whether in the process you consider that the test has give you enough validation and you now can sign, and then you just do the scanning, or even before, right? Like, the idea is to scan, always scan often, and then you can define where you suffer one step before or after.
Yeah, thanks. I get the point.
Thanks. Great questions. Interesting stuff. We're right about halfway, so we'll go ahead and if there's any other question, we can follow up in chat directly with the folks. We'll go ahead and move on to our next talk, which is Chris Phillips from Anchore, talking about some SBOM action stuff, which will be great. So yeah, take it away, Chris.
Great. Thanks so much, Zach. Hey, everyone. So first thing I'm going to do, just to not bury the lead, in chat right now, there is an SBOM action link. So that'll just take you right to the GitHub repository that has the SBOM action stored. And then without further ado, let's get started. All right. So this is the GitHub action for SBOMs. So we're taking this idea that Hector and Dan kind of put out there of this huge supply chain totally being configured and people not having to set up individual steps. And we're moving all the way to the right, and we're just going to be demonstrated one of those individual steps that you yourself, the developer, can configure pretty easily using a GitHub Actions kind of workflow. So not scanning, not the whole supply chain, just one piece of the kind of large orchestration that you can do today on your open source repos. So like I said, my name is Christopher Phillips. I'm a senior software engineer for Anchore. I'm on the tools and integrations team. So all the cool open source stuff you might see, which is Syft, or Grype, or in this case, the SBOM action itself. That's what our team focuses on. So we're going to cover literally like the level of knowledge of what this presentation was going to be. So we want to make sure all the context is there. So we're just going to talk about why an SBOM to even start off with. SBOM stands for Software Bill of Materials. For those of you who are kind of coming into the supply chain space for the first time, we're going to talk about the bill of materials formats that are out there. Already in the chat, we've seen kind of a comparison article of why SPDX or why Cyclone DX. SPDX stands for Software Package Data Exchange. And then if you think of Cyclone DX, it's Cyclone and then Data Exchange. Both are kind of released by separate organizations, but trying to move towards the same goal. So we'll be talking about those. And then we'll cover actually generating one of these SBOMs for your code or for your organization or for kind of whatever you see fit to integrate it with. So why software bill of materials? Why are we even focusing on this? This is a formally structured list of components. So what you want to think about is in the world, when you go out and you consume any kind of like bag of chips or steak or any kind of food, there is a recipe and label of all the things that went into making that thing what it is in front of you, whether it's the protein, the materials, the ingredients, etc. Software is kind of the same way in that when you look at this bill of materials, it is all of the components, whether it's transitive or direct dependencies, that go into making the software in front of you, that compiled binary or that package or that Docker image run. So an example, if I am using Golang and I depend on the Go container registry library, I should see that as a list of ingredients into my Golang program that's talking to containers or pulling out the layers, etc. We already talked about the multiple formats with different information. We'll cover that in a second. We also want to think of this not as just a generic kind of list or like flat structure that doesn't talk to each other, but more of like a graph. So each node in this graph is this component. These components have different relationships that talk to each other, whether they consume one another, whether they're kind of horizontal in children, they consume each other if you allow that kind of cyclical relationship, or if they have like kind of vulnerabilities sourced on each other. You'll see the SPDX spec gets very detailed in how the relationships can be associated between the different components that get generated. And finally, like this is the most important part. We want to start talking about how we share information about our software across these release boundaries. So if I go to the Anchore release page and I pull down Syft or I pull down Grype or I pull down an action, that shouldn't be the end state. I shouldn't just have the checksum and say, thumbs up, that checksum is great. I should have this programmatically generated list of components that I can stick into something else that then says, yes, this was attested by Anchore. And yes, it was signed by the Anchore kind of golden key. Oh, and yes, all of these components do not have current reportings in the National Vulnerability Database that could make it hazardous to run on your machine. So we're trying to move away from just, here's your software, I don't know, you run it kind of deal, and more validating the components that go into it and getting a kind of shared trust across these release boundaries. The advantages we just kind of covered. So obviously the software transparency. One of the biggest ones I wanted to highlight is that not just with checksums, but think of in the concept of reproducible builds, kind of the holy grail of like a CI process where you can keep generating the same thing over and over again from a set of inputs. If you have a hash that identifies, if you take like kind of the struct or the kind of data shape of a component and then build this hash that's repeatable over the course of build times, you can then say this build at this stage and this build at this stage are exactly the same for these different components. You can diff against them. And you have this kind of idea that SBOMs over time generate a history and kind of a formation of your software that can be checked against each other. And this is, this is the all towards building that foundation of what a secure supply chain looks like. The last one, and this kind of is understated, but it's super advantageous, is kind of the Linux Foundation and kind of overall organization backing of what SBOMs are becoming. I come from a banking space. I used to work at Capital One. And when it comes to these really formal specifications for NTIA and when SPDX like launches stuff, and if the different small government internet organizations get involved, people and developers just go, oh, well, my industry isn't highly regulated, so I don't need this. Actually, that's not the case. If you go to the opposite side of that and start looking at the Linux Foundation and Kubernetes, and even things like the supply chain levels for software artifacts, which is the SALSA framework, these high-level, hugely open source efforts are starting to back and consume and say, no, SBOMs are becoming required. They're becoming part of the conversation of what should also be released with your software. So we're not just in a space anymore where it's only the highly regulated, like military or bank or health, right? It is becoming a norm for all of software that this kind of standardization and like attention to detail is becoming required. So I think that's one of the biggest things to highlight, that supply chains are becoming important all over rather than just in smaller areas. All right. So let's take a look at what you can do as a developer to build an SBOM for your individual projects. If you're not familiar with GitHub Actions, don't worry. We're going to go into a workflow of kind of what that looks like. But what I really want to highlight, the biggest thing that comes from this is that if you look at my cursor here on the right, where I'm moving, you can see, let's go up. You can see it only takes 3 lines to get started. You would say, I want to use our new action. I want to do it with, in this case, we're doing an image, but that image can also be supplanted with dir or with package or with, there's a couple of different field names that allow you to select what you want to scan. So it is 3 lines in an actions file that can start getting this released. The idea is that we want to either be scanning container images that are released or directories of software, and we want to take those scanning outputs and publish them with cutting a release on our GitHub page. We also want to make sure that people, and we're sensitive to the idea that if you have a private registry, you can do that as well. So with a few more lines than just the 3, you can start talking upstream to any kind of place that you're publishing information that doesn't have to be super open source or is behind some kind of natural security that you want to put. The analysis itself of building this document is based on our other tool called Syft. If anyone from Anchore is in the group, you can post Syft in the chat so people can go and head on over to there to see what this tool is all about. But we're kind of just wrapping this in an actions format to build and generate these documents. Cool things about Syft. We have and support many different distros. You can do APK, Deb, RPM. We also support a lot of different software ecosystems. So Ruby, Python, JavaScript. The example that we're going to be going through today is actually a Rust crate. So that's cool. We support a bunch of different kind of package metadata objects that get analyzed. And there's even deeper options where we do some kind of reads on disk where we're scanning images. So go have fun and check that out. We also want to talk about just the different output formats that are available. Obviously, the conversation surrounded, hey, do we support SPDX? Do we support CycloneDX? Do we support just, non-lossy JSON metadata? The answer is yes to all those. We support them. And to Hector's point, we're constantly developing on this to get them to states where they can be input into other tools that kind of keep connecting your supply chain across the different boundaries. All right, so we talked about it. Let's actually see what the anatomy of a release on GitHub Actions looks like for people who are not totally familiar with GitHub Actions. The name of my release here is upload, and then we're going to talk about the bullet when to run. So on release up here in the top right, you can see if a release is created, then I want, boom, my workflow, my jobs to run. Then we're going to do what to run. So in this case, we're going to build our cool little Rust program for Linux and for Mac OS for these different architectures. Then we're going to check out and pull it all down. This lines 27 through 36, 37. That's all of the Rust toolchain of saying, hey, take all my actual human readable code, compile a binary, and stick it somewhere. Finally, on 43, we see this build archive. So above build archive, you can see I'm generating spom.spdx.json. That's awesome. That file now, if you see down here, where did we go? Target release is eventually going to be attached to our release asset on the GitHub page. So after we've generated spom.spdx.json, the action itself is going to put it onto the release asynchronously. So under build archive, you don't have to stick it in your tar.gz. Under upload release, you don't actually have to tuck it all up there. The action itself will take and start pinning things to the release in separate threads. So just like build archive is going to build and then upload it, so is the action going to asynchronously send it on up to the release. Let's check out a live demo because, as Linus would say, just show me the code. All right, so this screen should be very familiar to everyone who's ever worked on GitHub before. These are your release pages. I would like to draft a new release, and I'm going to make a brand new tag. So for this demo, let's anoint our Rust clock application to v0.1.0. We're going to create that tag on publish. We'll call this v0.1.0, and then we'll describe this as simply as possible, v0.1.0. And I'm going to publish this. Awesome. Let's go to actions and let's see the release actually happening in real time. So you can see the two jobs for the matrix are now running. I've got Linux and I've got Mac OS in that. We can go back up and see in our release present. It kicks off both of these builds, so build Linux and build Mac OS at the same time. And now as these builds run, what is eventually going to happen, if you see here on my left-hand screen, I'll pull down a previous release that was done. So this was our v0.0.2 just in testing. And if I vim sbom, you know what? Let's do this instead. Yeah, vim sbom.sbom. You can see here that my release has produced an spdxref document for, oh, that is the wrong tool. I pulled down the tool one, the Syft one, and I'm so sorry. Excellent. So we used Syft 26.0 to actually generate this. And now if I start banging through the different packages here, let me highlight on the ref, you can see we have the Rust crate ANSI term that's been highlighted and been analyzed and seen within our package. We've also gotten our, let's find another good one, Rust crate chrono. So we're using chrono to actually build the clock within our application. And then you can see here on the right, oh, it's so fast. I love that. The sbom action itself firing and running Syft against our directory, which is what's generating this sbom here on the left. So now if I go to our clock releases page and we check out our latest deployed 2 minutes ago, you can see our sbom spdx.json has been attached to our release. And then this can be used by consumers of our application or downstream in the flow to be put into different analysis tools, or for, again, like I said, people consuming our tool to say, hey, my software is safe. It's signed off by Anchore, or in this case, just Chris Phillips. And you can go, to your merry way and use the clock application. So that is the sbom action for GitHub Actions. It's 3 lines of code to start generating an SPDX JSON or the kinds of formats that you need and attaching to a release today. If you have questions or want a walkthrough of how to do it yourself or how to integrate it, let me know. You can find me on Slack, or you can just ping me via GitHub and I can always help you out. All right. And that is the sbom action for GitHub Actions.
Awesome. Thanks, Chris. Any questions?
I do
Nice
again.
demo.
Can you distinguish, does the sbom distinguish between those items used to perform the build versus those items that are actually shipping components that are being redistributed?
That's a great question. So in this case, the analysis does not target the tools used during the build. It is doing a scan of the directory of the source code and is saying, based on this directory, and then it goes, hey, that's a cargo.toml. Let me take all of the metadata about that, go up to K8s.io and generate the full kind of package listing that is going into the software itself. So not saying GitHub Actions is running, let's say, CentOS version 7, so it's super out of date, and then popping that into the SBOM and saying this was built on this machine that does this thing.
Well, but you're I'm not a Rust developer, but in other languages, Python, you very well could pull in a bunch of development dependencies, and maybe, but even so, maybe you didn't put them in development dependencies, you put them in regular dependencies, but when you actually package up and you actually create whatever it is that's being redistributed, and again, I come from a proprietary world, so we're always very paranoid about knowing what is it that we're redistributing to our customers, because that's when the open source licenses kick in, is that distribution process. So just because something's listed in a setup.py in Python doesn't mean it's actually what's redistributed. And so I try to be very precise in actually examining what is built and what is actually in that entity that is being redistributed.
Yeah, this is a really good question. So if you go and run Syft against even a Python distribution, you would see the metadata for those dev dependencies allocated under the document. And if you want, though, there are a bunch of configuration options that allow you to ignore and to remove those. From a development perspective, we did not want Syft, or we did not want our tooling to ever make decisions on behalf of the developer to say, oh, we're just going to automatically exclude this metadata. We want whatever is displayed at the end result to be as close to the source of truth of the different data sources, whether it's the dev dependency list or the dependencies list, right? And say, this was detected and possibly used within the build process, even if it was a dev dependency and even if it might have not been compiled in the final thing. That's why you see some transitive dependencies, and that's why you also see other packaging components that exist in the final output. I apologize because I thought your question was specific to Syft talking to the build tool itself that was running and generating the SBOM. So again, scanning the image that GitHub Actions might have used to produce the software.
Yeah. Okay. No, that answers my question. Thanks.
Can you customize the fields that are generated by the SBOM automatically? I'd like to have a package homepage. That's awesome. That's Dan, I think we can start looking at adding an issue that could allow us to do that. We are digging into the SPDX spec right now. So if a field is missing, or if there's optional fields that developers would want to add, I'm sure that's a config option we could help facilitate. Yeah, great question, Jay. For reference,
maybe I have one question also. Do you have any experience on how reliable the information actually is that you can retrieve via Syft? I mean, it's always attached to the packages, right? And I have come across so many packages telling me that they are licensed under GPL, and then I look into them and they are licensed under MIT, or that they contain nothing, and I look and there are 5 sub dependencies inside this package. So do you have any feeling of is what we get here, is it just good enough for management to make them go away, or is it really reliable in the sense that years after someone will ask us and we are quite sure that we have found everything?
No, we want the data to be as accurate as possible, and not just a stop bugging us, go away kind of signal. There are a bunch of regression tests that exist within the Syft library that get run every time against known images and known listings for different fields that we assert on, but we're only as good as our community. So if you do find false positives, then we would very much, or something that's not being displayed, we very much encourage anyone on this call who's using the tool to file an issue. We try to be as responsive as possible, both in our community chat and on the issue board, to make sure that if you find something where it's not accurate, that we get up and get that fixed, as correctly as possible. The other day, we had something where I think how we were decompiling the Go binaries, we'll take a Go binary and decompile, and we found that the version was just being overwritten, and that was a community member that reported that. So we came in and we fixed it immediately. We found the regression, added the test, and went on from there. So the more that we can get as far as those niche cases that might confound, the better.
But in the end, doesn't this mean that you sooner or later have to start some kind of knowledge base? I mean, you can only be as good as the data that you get from the packages. So if someone fucked up there and they have like the wrong metadata in their package, you can't do anything about that, right? And I get the feeling that the commercial players like the Black Duck people or something, this is their strong selling point when they go to big companies, that they tell people, listen, it's not true what's in the internet. The only thing that is true is in our knowledge base. And do you see any chance of building some kind of community-based knowledge base here that we can start and grow something like this to just outperform this proprietary knowledge bases that those vendors have?
That's a Dan Loring and Zach Hill question, because I think they have been involved in a little bit of discussion for that on the Anchore side. But from the tooling side, that is, I mean, just from face value, that is a great idea to take that kind of closed knowledge and make it as close to open as possible. So go ahead, other Anchore folks, if you have discussions or ideas on that.
Yeah, and as a side note, so for what you're mentioning regarding, so like, you know, we're as good as the data we get, and that's definitely true. So if the package manager is lying to you in that point of view, if the packaging metadata is lying to you, that's not something that we can go out and verify. This is where, like, you know, us and Black Duck, there are two different use cases there. So where those kinds of tools are, like, you're operating in an environment that you don't trust, so like you trust nothing. And so here, you're for these kinds of tools, there is some trust involved. Like, we, you know, looking at the artifact itself, we're going to raise the information that we find. And so that's a really important distinction, is we found X information. And so that's, I guess, a distinction I wanted to draw there. Yeah.
I think there's a couple of interesting notes, I mean, around this question that we can go into first, which is, I mean, certainly it's true that we're as good as the data we find, but the system does like recurse and look for everything. So it doesn't just like stop at the top level, you know, package metadata and just trust the entire like file tree below it. So if it finds more stuff nested that's actually being delivered like in the package and stuff, even if it's not declared at the top level, like we recurse through and find it. And if it doesn't work quite correctly, that's a bug, and we'll resolve it. So that helps in terms of like, you know, they didn't declare a top level dependency, they just vendored it in, you know, those kinds of things. If there is metadata in that vendoring path, they can be found. The other aspect that I think you're talking about is, it tends to be more license specific, and that it require, you know, that depends on where you're running it. So the folks like Black Duck or others that you want to build the data, you have to find the source to vet that they're lying in the build artifacts, like when they don't match. So yeah, we've talked about that. Something we can follow up and discuss in a place where we're looking at somewhat on the product side as well. So that'd be an interesting discussion to follow up in terms of, you know, correlating what you're finding in the build to the thing that produced the dependency that you're pulling in. And for some ecosystems, those are the same, because they're, you know, Go, it's pulling the entire source repo down. Others, it's a compiled artifact, a jar, or whatever, and there's not full information at that level that you can understand. So it's a great topic, and you know, we could certainly follow up and would love to chat with you about that.
If I could just interject a couple comments here coming in from this space. Yes, packages are notorious for being inaccurate at the metadata level, at the top level. You really do need to do the analysis of the source files. And even more particularly when you actually do the build, find out exactly which source files made it into your build to have accurate licensing. Okay, that's kind of where we need to go. You're seeing some of the packaging infrastructure starting to pick this up. I like this notion of the GitHub Actions. I think that's super cool that you're putting that in to make it easier for people when they're building things to work with Syft. So that was really cool. And then to answer your question, there's been a couple of attempts at creating a community repository. There was some work that was done for Clearly Defined is the name of the project, but they were not being able to form a community around it to keep sourcing things together. So Microsoft did a lot of work on that project for trying to serve source metadata. And so there's partial efforts out there to potentially build on and articulate, but we don't necessarily have something that we've seen people rally around. And I think as we can get more of these SBOM documents shared and people being able to extract them and people will be able to look at them I think that'll be the way we can start to build up more of a common repository by mining these documents as they emerge and are put out as service as a default of a release, for instance. Thank you for letting me interject.
Yeah, thanks, Kate. Yeah,
Sure.
for those that don't know, Kate is highly involved in the SPDX project. She's one of the big folks there. So thanks for joining, Kate. Many thanks. Any other questions?
Yes, I have a
Comments?
question.
Mhm.
Do you have plans to include attestations also to the SBOM action? At the same time, you generate the SBOM file?
Yeah, just seeing how the space is like opening up, I think we're going to have to include that sooner rather than later. Attestations are becoming a huge part of, like, just if you look at the SALSA framework for supply chain levels for software like artifacts, just it's not good enough to just say here's the document, right? There has to be, whether it's a GPG sign or something that says, yes, this is my document, and yes, it's signed by this special golden key that is only mine and no one else can use. That is the de facto standard that we're kind of moving towards for verifiable and complete SBOMs. So yes, the answer that it will have to eventually be in there.
Thank you. All right.
Great. I've been and appreciate all the questions. Great discussion. We can certainly follow up in Slack. We're coming up on time here. We have a few more minutes. So if there is any more questions, we can certainly go through those. I'll go ahead and put the wrap up slide, but we have a few minutes left. I just wanted to make sure that we didn't run out of time to remind we have a Slack community, anchore.com/Slack, that we'd love to follow up discussions and chat with everybody there. Contribute to Syft and Grype. We always appreciate the stars if you're enjoying those projects. We also have a link up here you can see to follow what the folks at our Cartographer are doing and get involved in that community. And if you want to speak at any of our future meetups, we're always open. We love to have folks come and present on the interesting stuff that they're working on. So ping us here in the Zoom chat or follow up in our Slack, and we're happy to connect and make that happen too. So if there's any other questions, go ahead and do that. We can feel free to follow up there. We've got a few minutes left, but otherwise we'll wrap up shortly. Great. I'll give it a few minutes. All right. Thanks everybody for joining. Great presentations, Hector, Dan, and Chris. Many thanks for presenting this awesome stuff for all of us to see. And we will see you all again soon. Again, should be getting an email follow up with this in the next couple of days or a day or two with the link to the recording, etc. So you can rewatch anything that you'd like to. So thanks again to our speakers, and we'll see you all again next time.